Welcome to our epic adventure with PowerApps and Power BI. This is going to be a talk on how we created our PowerApps game, how we stored the data in a SQL Server database, and then how we visualize the information in a Power BI dashboard. So just as a quick introduction of who we are, my name's James Solon. I've been a Power Platform developer for about 2 years now. And I've recently joined Simpsons Associates to head up their Power Platform development. I've got Matt Bean here.
Hey everybody, so my name is Matthew Bean. I'm a senior consultant with Simpson Associates. Been with Simpson about 5 years now. Mainly specializing in databases, bit of Power BI, and sort of all that lovely backend stuff as well.
And hi, I'm Lee John. Been with Simpsons since September last year. I do anything and everything I can in Power BI.
We all work for Simpsons Associates, which is a data analytics company covering the full Microsoft stack. Just in terms of what Simpsons Associates do, we have the ability to take projects from inception, discussing design strategies, design implementations. We'll then do the technical implementation, and then we've also got the ability to do post-delivery support. And as a great example of this, we've got this Power App game that we built. So just as a quick, brief agenda, I'm going to have a chat about the game design, how I built a D&D game, and then going to give you a very quick run-through of the game and all the important elements that I've put into the Power App. We're then going to go into the data engineering side with Matt, and then finally the data visualization at the end. So I know absolutely nothing about D&D. When the marketing guys came to me with the idea and said, we're doing SQL Bits this year is D&D themed. Can we make a D&D game? I was like, yeah, right. How hard could it be? Turns out a little bit tricky. There's a reason why this whole degree is devoted to games design and things, which I now understand and appreciate. But yeah, so asking Simpsons Associates guys around, there's quite a strong D&D influence within the company. I figured out that D&D is all about role-playing. It's a role-playing game. It's all about role-playing. It's all about creating your characters. It's all about dice rolling. Chance is a very important element of D&D. It helps create the story. And essentially, as I was reliably told, it's just a war game with a story slapped on top, which apparently is controversial, but anyway. So the main features of D&D is the character. You want the character to have a really good backstory. You want the character to feel like it's progressing through the game. You want the character is doing something unique and individual to that person. They can really start to embody that character. The map is where all of the events happen of that character story. So you need to make sure that the map element is key. It's central to the story. It's central to everything that's going on. It's the stage that the story is set. And finally, monsters as well. They're why you're having this adventure. You're trying to attack the monsters. You're trying to get loot from them. You're trying to beat the monster and become the greatest hero of the realm. And crucially, for everyone here, it's all about the data, really. All the characters have attributes. They all have stats. All the monsters have stats. And creating a game, I can just scrape all the information. I can pull it through. I can record it all and then kick it into a database for these guys to play with. So, as a quick games demonstration, if I just switch over and do the very risky thing of doing a live demo. So this is the character creation screen that you can see in front of you. Up in the top, we've got 3 boxes. We've got character name, previous occupation, and age. And what I wanted to do with this Power App is make it look nothing like your standard Power App that comes standard out of the box. So pretty much everything you see on here is a custom component. So there's none of the blue buttons. Everything is being built using low-code solutions. So I'm just going to give my character a name. He's going to be a blacksmith, and he's going to be 21. He's going to be. I can then select a class. So he's going to be an archer, and I've got all my stats, which have been generated on the side. I can re-roll those, depending on if I like them or not. And most fun is I've got character backstory here, and I can also create an image. So I'm going to create my backstory, and I'm also going to create an image. And what this is doing is using a Power Platform connector that a chap called Robin Grunson, I think, he's a German fella, has built. It's a really low-code solution that basically you just patch in your GPT-3 bearer API key, and then you can feed it a parameter. You can feed it a prompt. I've inserted three parameters into that prompt, and it comes back with this story. I've told it to give us a rag to riches story, and interestingly on this one, the parents don't die. Usually the parents die, which is a little bit awkward, but never mind. Using exactly the same connector, using exactly the same prompt, I can also create some images. So this is reaching out to DALL-E, OpenAI's image creation toolset, and it's just made this entirely unique portrait of the person's character. So as soon as I'm happy, I can click enter. I can ignore that error. And then I go into the inventory screen. So this inventory screen is using another feature of PowerApps, which is PCF components. So these are a little bit more advanced components. This is a component that someone has written some JavaScript for. And what this allows you to do is drag and drop my wooden sword into that box, which you can't do natively in PowerApps. But if you use a connector, you can use a PCF component, you can really easily. So I've not had to script any JavaScript to do this. All I've done is just pop the things into the right boxes, I filled in the right parameters, and away I go. So I'm just going to save those steps, and then I'm going to go into the dungeon. And in the dungeon, this is the map screen. So what I've done here is I've created a little map with a little character, and using WASD, I can move the little character around the screen. And when he steps over an item on the map, a prompt will come up, and that's an item. If I step on the skulls, it launches a battle. So I can then go onto another screen to figure out to show the battle showcase. So I used to play Pokemon when I was a little kid. It's kind of quite similar to this, but you know, yeah. The images for this have been made with another AI program called Midjourney. So I've used AI as much as I can just to make all the image assets in this game. So I can attack it, and send it through. So that's pretty much the game in a nutshell. The idea is to get from the start all the way to the other end. There's 4 levels, and the final level is a boss level where you need to fight the big dragon. Just going back onto here. So to make this, what we've built in the background is we've got a SQL database. What we've got there is a lovely normalized initial database that I sketched out. It grew quite a lot in size. Apparently, Matt doesn't like it for some reason. No idea why. It's great, and it worked perfectly for me. I needed a storage account to store all the images that we're creating. I needed to have an OpenAI connector, component libraries, and PCF components. So on the character screen, what's happening here is the methodology for me doing this is I have the blue buttons in a dev container down at the bottom. So these buttons always exist, but the user can't see them, just so that it just enables me to have faster development. And so when you click enter here, instead of actually firing the code from that enter button, it's firing it from, I think, this value here instead, this button down here. And the GPT prompt for this is using the DaVinci Code 002. It says, you are a dungeon master writing a game of D&D, introduce the character. And these are the prompts highlighted in different colors. On the inventory screen, I used a PCF component from Scott Giroux, which is available on GitHub. You can download it and use it and play with it. And all of the components that you've got on the far right-hand side is the components that you use, or the parameters that you use to play around with this tool and make it unique and make it work correctly. On the battle screen, this is where I start to scrape some data. So when I initially made the database, it worked really well for me. Lee and Matt came to me and asked me to change some things a little bit. So I then started to create some wider tables, which are apparently a little bit more useful for them. Because the database that they've got going on is, the Power BI is using a direct query into the database. So they need wide tables rather than tall, thin tables. So I started introducing more wider tables. And then finally on the map screen, I don't know if there are any Power App developers in the room, but some of the guys who come down to our talk have no idea how I've managed to do this. What I've got going on is a timer. Every 10 milliseconds, it's checking to see if there's a character input in this text box down at the bottom. And whenever there's a character input, WASD, it will register that character moving left or right, up or down. And the map itself is just a grid of numbers. So whenever it's moving right, it's adding 10. If it's moving up, it's minusing 1. And it's just navigating the field through that. Yeah. So that is the code that's powering sort of, you can see WASD. That's just sort of registering and writing the code into the cache. Whenever the character finishes a floor, it will send all the data for that floor into the database, so then that information is ready to be viewed. So theoretically, when someone is playing the game, you can also look across the Power BI dashboard, and you should be able to see your data as soon as you finish the floor, which is quite cool. And, yeah, I'm going to hand over to Matt now to talk about the architecture and data models a little bit more.
Awesome. Yes, so onto the lovely, lovely database. As I said at the start, my speciality is not really in the realm of PowerApps. So the database side, the Power BI side is much more my cup of tea. So when I was brought on to do this, to help basically build this sort of live dashboard that Lee was going to do, help build the database behind it, James had already set up a sort of pre-database, which was really functional for his Power App. So when I was brought on, I was a bit daunted by the task of basically integrating this Power App into a system. I've never really done this before. So for me, I like to put things in a perspective which I can understand, so based on a database. So let's have a look at the architecture. So what we have is whenever James starts up his Power App, it basically reads all the data it needs from our database. It pulls that data in. This is all stuff like monsters, the monster attacks, what damage they're going to do, all the other metadata around how the game's structured, so cells, cell locations, all that thing as you move through the map. The other thing that the game does is it reads from our storage account. So we have a storage account which hosts all images. So basically, when James starts up the game, it pulls through all those images as well to build that sort of structure behind the actual sort of user interface and the maps, so you can see where you're actually moving through and going through. But on the flip side, PowerApps are also writing data. So when James pushes out to ChatGPT, pulls back that character backstory, that's going to be written into our database. When James goes out to the DALL-E 2, gets those character images, those are going to be written to the database as well as a live connection. Sorry, not to the database, into the storage account. So we've got on the fly images being written and data being written. And on top of that, whenever you do any movements around the game, any battles, any wounds that you inflict, any damage that you take, any treasure you find, all that stuff is tracked and logged in a database. So from my perspective, when we get into the Power BI, this is basically just a online transactional database. It's basically taking live data, and we've also got a storage account as well, which is taking some sort of live data as well with the images being written. So the Power BI is obviously going to be reading that data. We want to take those images from the storage account live, so you can see as you play the game how you rank, where you sort of stack up in the actual leaderboard that we have on the other screen to the right. So how does this all hang together? So you can see here, this is basically the structure we've got. We've got a Power App in the center, and we've got the Power BI report to the right. We've got our lovely database and storage account, the rose between two thorns, right in the middle of it. So basically the way the connections work is we're using shared access signatures to read and write from the storage account, using basically URLs with sort of the access key on the back end of it, the shared access token. And we're also going to be pulling that data through, because we want that live dashboard. We're also going to be pulling that data through from the database using direct query. So the question is, the problem I found was, how are we going to get that live connection? Because there isn't direct query to a storage account. How do we get that live connection to the actual image storage? So it's not technically a direct query live connection. It's a bit of a workaround. So whenever James or you interacts with the game, you create a new character. That character has a row with a unique identifier. So what we do is we can create a file name based on that. So typically it's just the character ID.jpg. So James writes that with that name to the storage account, and then we can take that field as a computed column and basically concatenate all the sort of lovely URL stuff together with that file name in the middle. So you can see we've got the actual directory path, character images, I think is the blob, and then the actual file name of the image in there. So whenever that new row is inserted, Lee's report can actually read from it. It can find that URL straight away and then basically pull that from the storage account. So it's not direct query technically, it's sort of got a middle step in between it, but it's just about live, and it will pull through whenever something's written into the storage account. Cool. So from my perspective then, what are the requirements based on this? So we've got a Power App, which needs to be efficient for read and writes. We've got Power BI, which needs to be efficient for direct query to get the live data through to the model. And we also want to maintain that functionality of the game, so allowing James's game to run smoothly as it did when I first came onto the project, and also allow that comprehensive data analysis that Lee needs so he can build his cool Power BI report on top of it. So let's have a look at how we can make a Power App efficient. So the vertically is showing the sort of time taken as a sort of like a rough estimate. The time taken, total time taken all the way down. So you can see each section, we've got a sort of a process going out to the data source and coming back again. And you can see the time taken. API management and connectors are basically outside of our control. So we can't really do very much with those. But on the other side, data sources and the client-side connections we can do a lot about. And you can see that's where the biggest load, the biggest sort of lag is going to be between our data getting written and read from the database. So how can we actually minimize these? First of all, minimize the amount of data that we need to ingest. Obviously, large amounts is going to create massive bottlenecks. We also might have to do more complex queries, bigger load on our actual read and write. The other thing that we need to do is to minimize the compute capabilities on the client side. Obviously, if we have a SQL database, the engine's much more efficient, and we can actually push all that compute load to the SQL server side, and we can sort of scale up there rather than having to push up costs in our Power App itself. So we can centralize loads in there. How do I scroll down? No?
Not sure you can.
So the other thing actually is geographic location. So you can see, well, if we have a database in, let's say, Spain, and we've got our Power App in the UK, it's going to have to do a massive geographical, it's going to have to travel long distances to basically get out and pull that data back as well. So we can minimize delays by keeping things centralized in the same location. So how do we actually optimize our Power App? So as I said just then, geographic locations. If we can have our Power App in UK South, we can have our Azure SQL database in UK South. It's not going to have to travel very far. The other thing is highly normalized tables. So if we can basically allow James to minimize the amount of data he has to write, one row per one piece of information that he has to do, one row per character classes. So if you can make that as normalized as possible, there's going to be minimal data that he has to actually write. The other thing is views. So we're trying to minimize that load on the client side. What we can do is we can actually create views on top of our database. And that means we can ensure that when we do those queries out to the data source, we're making sure that load's actually hitting the Azure SQL database rather than the actual Power App itself. And the final thing, obviously for the Power App, we've got read and write capabilities. So we want to try and limit we want to try and find a balance between the two. But indexes can really help with that sort of query time, that query load, when we're actually doing queries to the database. So on the flip side, for a Power BI report, we've got direct query going into our database. How do we make that efficient? So for me, obviously this is key to all you Power BI guys. You know, star schema is the way to go. We want to build that big fact table. In our case, that will probably be movements around the game. We can store all those movements in one big table, all those events as well in there. And then on the outside, we'll have dimensions surrounding it. So that's things like characters. We want to slice by characters, so we make a character dimension so we can see the movements for that character in the fact table. The other key thing as well is to prevent those zero-to-many relationships from the dimension to the fact table. So getting rid of those, putting an unknown value in there so we can make sure those links are basically as complete as possible. And that can really speed things up as well. Once again, indexes, same as before. We want to make those queries that we have to write really, really efficient. So we can do the same it's the same for Power BI as well. The other thing, because Lee's going to be reading a lot of the data, is we want to materialize it. By this we mean any of those computed columns. So for example, the URL that the live connection URL, we want to compute that column, but then we can actually persist that data. So every time Lee does a query to pull out an image, that's going to be kept in the database and persisted, so we don't have to keep rerunning the same transformations over and over again. Another thing is to design your database with DAX in mind. So me and Lee have had a lot of back and forths, poor guy, basically trying to minimize the amount of Power Query we have to use. I think we've basically eradicated Power Query just about. And
Apart from 2 o'clock in the morning, we write the database, write everything.
And basically minimize that DAX logic that he has to do, so it makes everything more efficient in the actual front end, reducing that load once again. And the final thing, I mean, in this case, it's not really applicable, but if you have a sort of Synapse workspace, Synapse dedicated pool or something along those lines, you can then use distributions as well, which can really, really speed things up if you have those capabilities. So for me, there's 2 balances here, and I guess it's the same with a lot of online transactional databases, and just trying to do that direct reporting on top of it, is finding the balance between the two, finding the balance between the read and the writes. So for James, he wants to write minimal data. That's highly normalized tables,
Beautiful.
lots of splits, lots of snowflakes. On the flip side, Lee wants that star schema, so he can make really, really efficient queries on top of the data. So you've got to find some sort of trade-off between the two in most cases. I was quite lucky in my case because I have direct access to the writing technology, so I can ask James to change things on his side. Normally, we wouldn't have that privilege. Normally, we'd be basically building horrific sort of views on top of the data to try and get that star schema. So I've been quite lucky in that aspect. And the final thing is indexes. So like I said, if we have indexes, read capabilities are better, but on the flip side, writing is going to be a little bit slower. So it's trying to find that balance. You might have to do some tests to see. Sort of how write's going to be influenced and how read's going to be influenced, and just sort of maybe some trial and error and some query plans to sort of see what actually optimizes your database in both aspects. And you can also prioritize those things as well. So, for those of the faint of heart, look away now.
It's great.
This is
Enjoy it.
This is the original data model. Really great for his app. It worked perfectly. Really, really efficient. But on the flip side, we've obviously got lots of horrific snowflaking going on. We've got attribute tables upon attribute tables. You can see with the characters to the player, to the characters and players and character classes, which we really want to try and avoid for the Power BI data model. We've got even a many-to-many relationship you can see there with the character runs linking to the character movements. So all this stuff's terrifying for us Power BI guys, as you all probably know. So for me, I was lucky in the sense I can go to James and say, look, we want to change the way this is written. We want to make these things unique between each other, and we can merge things together. So you can see here we've got the facts in the middle. We've got our sort of dimensions on the outside. And what I've tried to do is color code everything so you can see what we've sort of merged together and combined together to make that star schema. Some of the difficult ones, so characters is obviously being written to every time you play the game. And sort of similar to the fact tables. So for characters, we can't actually directly merge all that stuff together. We want to keep it sort of normalized for James's sake, so we can keep things separate. So we've still got the separate tables, which are fixed, so the character classes, James can still read off that really easily, but we can merge the things that are written into a one-to-one relationship. So that data is basically in a star schema, normalized dimensional format with a one-to-many relationship to our fact tables. The other thing I was quite lucky for is we've got the monsters and monster classes at the top. Because that data is basically fixed, and it's the same with the cell items, the cells, the cell type, and the floors, that data is basically fixed. Unless James adds a new floor or a new monster to the game, that stuff can be basically persisted in the database as a merged table. So then we can just run a sort of micro ETL inside the actual online transactional database to merge those two together. So we have a sort of star schema-based thing. And what we can do as well is we can keep those split out. So James can have his 3 lovely normalized tables. He gets really efficient read and writes to. He gets really efficient reads from. But we can also make a sort of a fixed dimensional table as well, which merges them all together, which we can then use in Lee's model. So let's have a look at the model. So you can see characters there merged together. But we still have character classes separate, so James can do a really efficient read, and the same for the cells. You can see the map cells tables merged together as well. So you can see now everything lovely, one-to-many relationships, star schema all the way, which is great. So my lessons from this, like I said, fairly new to PowerApps, but as these guys will tell you, data requirements up front, because I've had to go back and forth with these guys and ruin a few of their evenings, basically, trying to change the data model so it's ready and good to go. Yeah, so all you guys, data requirements up front, all you people will know that's the best way to go. The other thing, if you can, with an online transactional database, is get your writing system to change, if you can. Obviously, very rare we'll ever be able to do that, but if you can actually get that to happen, it can make your life a hell of a lot easier and a hell of a lot more efficient as well. The other thing is to build with optimization in mind, so everything that you build in, you're trying to minimize the load on the sort of client side, on the DAX, and trying to build that sort of those right structures, basically to get you the most efficient database possible for all requirements. And also, any dimensions that change, try and persist those. So we persisted those so Lee could actually import them into the report. He doesn't have to keep querying those from direct query. We can have that efficient Power BI in-memory sort of data and keep that in the model. So yeah, that's everything from me.
There is a question online. It's not on the screen. How does your pipeline handle the possibility of high latency with your database if the user tries to enter multiple consecutive inputs? Can your database intercept multiple updates in one go, or is your Power App designed to lock the user from making consecutive actions?
So if in testing, the Power App was pretty good at just being able to pass information through. In hindsight, because we've got a little bit more of a latency issue at the actual event, when a user clicks on a button several times, they can skip a floor. So what I just need to do is put a little bit of a blocker on that button itself, so the Power App can just understand locally, okay, with that button's being clicked, I'm going to hold and stop this button from being clicked again until I've received the right data packets to say, yes, that the user is now on the right floor. So you can do that locally. I just didn't design it in, and next time I will. Okay, Lee?
Thank you. Over to me, the Power BI visualization side. So, just to let you all know, this is my first time presenting. I'm not a person that actually gets up on stage. I actually hate it. I'd rather do all the work and not present at all, or let somebody else take the credit. I'm sweating, if I'm totally honest. So do apologize. I might speak a bit fast. I am Welsh. We do tend to speak quite fast, and my English is not always coming across right, so I do apologize. So I've been in the field in data, mainly Power BI, for the last 3 years. My background is electrical and mechanical engineer. Through an accident that happened, that I'm not able to do engineering anymore, and I came in where my passion's always been, within data side anyway, building old school Excel. I spent 8 years in the Royal Navy submarines as a weapons engineer, so I spent a lot of time under the water, 6 to 9 months to be honest. In a tin can is not the best. 10 years in renewable energy, so I covered wind farms, battery parks, and solar energy. I was working on Pennacomoy Wind Farm, which is the biggest, well, I was the lead engineer for the biggest onshore wind farm in England and Wales at the time. And to let you know that I am extremely passionate about Power BI. I get quite passionate, so I do speak quite a lot faster. Hopefully I'll slow me down. If I do, raise your hand and tell me, slow down, please.
Will do.
So as we work with a lot of government sectors, police, NHS, and that, they like to use native visuals. Trying to get a game to work with native visuals has kind of been one of my tricky sides to do. I have had to use a couple of visuals that are not native. So Chicket, the slicer, if I'm saying it right, I had to use it for the buttons. The Microsoft ones, they're great to a certain point, but I couldn't find that I was getting the right look and feel and how I wanted it to work. And the other one is the play access. So when we drill through and you can watch a replay of the whole game playing that's been played in PowerApps. I've used that in order to replay the data coming through. And simple images I used then for scaling. I tried it in the card, I just wasn't getting the look or feel. Tried it in a matrix, yeah, there's no go on that one. So the other parts I've done is I've got a massive fields parameter. So I used Power BI's native fields parameter, and I just added a little bit of extra twist custom on it to give me everything I needed for my buttons. So within my measures, I have formatted them and that. First thing I do is I use a lot of external tools. I think there's 14 I use. I use them every day, practically. They're all great in all their aspects. Bravo is the first main one I'll probably use. That'll format and that, which is done by SQLBI. And then the other part, which I found out on a blog online, I've forgotten the guy's name, I do apologize. It was a cracking script. I just needed to tweak it a little bit for what I needed to do, which is going to do, basically, I think it's been on one of the shows as well. You're going to use ChatGPT, you're sending up each measure, it's bringing it back in a JSON file, and then basically embedding it. The limitations of it, so on this first one he had that he released, he didn't have the code, so you could loop through. So that was the part I was working on a bit more. He'd used it so that if you had an account, obviously me being tight as hell, I don't like to spread out too much. I try to save. Sorry, apologies. So just try to play with it and utilize it to get through. So moving on, yes, this is a Power BI report. I know it does not look like a Power BI report. I will take you through in a sec and give you a bit of a live demo. Touch wood, it works. We've used a lot of SVGs, created them all first. And then, but the only thing is when you save the SVG, it comes, we had 40 megabytes. So I just cheated a bit. Microsoft PowerPoint, I love PowerPoint being old school on my age. Copied the image in, saved it. It compresses it a lot more than I needed. It didn't take out too much of the look and feel pixels, but it got it to where I needed it to be, so I can embed it. I tested it first, just put in the UI packs we were using in order for the backgrounds and stuff. And yeah, I just needed to optimize. So that was the later on then to feel and design them up. Anyway, let's get on to the fun part, which I call the fun part. Are we on mine? Yeah.
Yeah.
So the Power BI report. So there is more pages, drill throughs, tooltips, everything else. These ones, you got the gameplay. Just show you all the statistics. I'll take you through in a minute. You got your character, all about the characters of each person, and then you got your monsters or battles you've had with. So I load up the page. First page. This will give me an overview of all battles that I've had. Just so you're aware, this is fields parameters as well, working with buttons, just in case you're wondering. Statistics. jQuery's letting me down. So we've got some statistics on strength, defense, attack, move directions. If I drop one down for each map, hopefully I'm selecting right, a nice one. And I move. If I select Alex, say for instance, it shows me on the right who he's battled with. Also, if I've got a map, if I clicked on the map, the series part, it'll highlight certain activities that are going on. I'm going to select the character because it might be easier. So in this one you can see there was caves. So you can see all the movement down here. So it highlights, shows you on the floor how many movements on the floor, normal floor tiles, how many foods they've picked up, monster tiles. So click on a monster. Wrong one. It's showing me on these. If I click on cave, it'll show me the cave ones. I have got times and battles and floor times. So I can see my battles. When there's more, I deselect one. So you can see on each floor and the battles, if I select on stewards, you can see on the right-hand side who they battled with as well. I've got loots, and traps. Get there in the end. And then I've got my ranking. So with the ranking, I've literally just ranked on whatever I could find. And then I've got an overall ranking. I've just ranked on all the rankings to pull in. So I've got an overall.
How many fields did you use for the rankings?
15, 16, I think. Maybe got carried away at 2 o'clock in the morning. Right, if I hover over the character, I can go for a drill through, a map play. Please bear with, I've got an imported version just in case, because this with direct query with the internet has been pretty good, to be honest, but it does have its moments. So you can watch the gameplay. Replay, as you can see, the character moves. The image from selected value on a switch will show which way he's going. The hanger comes down, health, and the gold. This is the only custom visual that's in here, is the play button for the play axis. The rest is, this is a matrix, actually. Bit of a DAX, having to go through it to get it to work, but I got there.
It's the character that changes direction when you're moving. I don't know if you can see on the screen, but when he's walking right, he looks right. When he walks up, he looks up. I have no idea how he does that.
I might show the boys later, maybe. So that's the gameplay. I'll take you through onto the monster character page. So you can see there's different characters. So every person that comes on has a background on the story, and then the class, and we can choose, we can swap and change. Alex, who is actually in the room, put your hand up. They're looking quite similar to most of the people and characters, so bit of a twist. And then we have the monsters page. There are drill throughs as well from the map, from the statistics page. You can drill through onto each part that you've battled with. On this page, Stone Golem, my best character that I liked, mid-journey, being a great tool to help. And then the other one was the Dragon Youngling, was one of my other ones that I enjoyed and liked. We have the background of them. And I'll hand you back to James.
Fair enough. Well, I think that's probably, do you want to think? I think that's probably us. The whole. Is there any? We've got loads of time left. Does anybody have any questions of what we built or how we built it, or anything like that? As part of the Power App, when you either win the game or lose the game, if you win the game, you get an epic saga written for you by ChatGPT-3. Only one person has had an epic saga so far. Everyone else has got some obituaries written. I coded it in so that the prompt was to be as sarcastic as possible. So, so some of the better ones are up here at the minute. So there's backstories and there's also a couple of obituaries. Does anyone have any questions, or are you all just reading what I put on the slide now?
If any of you got some free time, down, you're going to rank first. I'm not tweaking any of my DAXs to make you win. There is a Lego set that's up to win for whoever ranks first.
Oh, we've got a thing that we can throw around.
Thanks. I was just wondering if you managed to find what was causing the bug that causes you to lose your entire life force part of the way through the game.
Yep, that was a latency thing. So that was basically clicking too quickly. I just needed to put a little bit of a wait parameter on it, on that button click to say, okay, you just let everything send into the database, and then you're allowed to carry on.
Cool.
Yeah, if you're interested in the game, we're downstairs. We're part of the Simpsons Associate stand. We're always happy to go through how we built the game and have a bit of a chat in general. Yeah, it's been quite good fun building it, I think, really.
A lot of challenges.
A few challenges. It's been good fun, though. It's been great. Any more for any more? Okay, thank you very much. Please remember to give on the QR code and give us a like. Subscribe? Is that a thing?
No, Nick.